This was reality before the Big Bang. No time, no space, and no matter. So what could have possibly created something out of nothing? Truth is, we will probably never find out. We can only fantasize about theories. Was it some interdimensional being starting a simulation? Was it some event in a multiverse? Or maybe it was the touch of God. What we know for sure is that our universe started in an infinitely dense point, called the initial singularity. Followed by the Big Bang, we now have space, time, and matter. We have an universe. But how do we know it all started with the Big Bang? Because of these two American radio astronomers Robert Wilson and Arno Penzias, who discovered by accident the cosmic microwave background radiation in 1964. This event solidified the theory of the Big Bang. You can check this by yourself by simply turning on your TV, and removing the signal cable from it. The flickering you see on the screen is basically the echo of the Big Bang. Now let's get back to our really hot and expanding universe composed of subatomic particles like quarks, leptons, gauge bosons, and the Higgs boson. This is the standard model of elementary particles. These are the building blocks of our universe. A very important event we need to mention happened just after the birth of the universe. That is the separation of the forces, like gravity, electromagnetic force, strong force, and the weak force. What exactly are these forces? We don't really know, but we know what they do. The strong nuclear force is an attractive force between protons and neutrons that keep the nucleus together, and the weak nuclear force is responsible for the radioactive decay of certain nuclei. The electromagnetic force is a force that occurs between electrically charged particles, such as electrons, and is described in electrostatics as being either positive or negative. And gravity, which is a natural phenomenon by which all things with mass or energy, including planets, stars, galaxies, and even light, are brought toward one another. Now, with the fundamental forces being separated, the universe created new particles, like protons and neutrons. When the universe cooled enough, the electrons joined the party, and now we had the first atoms like hydrogen and helium. Now, with our universe being filled with gas, gravity started shaping the world and gave birth to the first stars. These first stars were massive, and they would burn their fuel within only a few million years. They would then explode, and give birth to new heavier atoms, so new stars and planets could be made. The remains of these supernova explosions are called nebula, clouds of dust, gases, and other elements. Some of the supermassive stars didn't only explode, but they collapsed under their own weight, resulting in black holes. A black hole is a region of spacetime where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light, can escape from it. Observational evidence indicates that nearly all large galaxies contain a supermassive black hole, located at the galaxy's center. With so many new elements and black holes, gravity further reshaped the universe, giving birth to galaxies. The oldest galaxy we have discovered in the observable universe is GNZ 11, which is a high redshift galaxy found in the constellation Ursa Major. GNZ 11 is observed, as it existed 13.4 billion years ago, just 400 million years after the Big Bang. About 13.5 billion years ago, our very own galaxy, the Milky Way, came to existence. The Milky Way is a barred, spiral galaxy with a visible diameter between 150,000 and 200,000 light-years. It is estimated to contain 100 to 400 billion stars and more than 100 billion planets. About 4.6 billion years ago, a very special star was born. Our very own Sun. Now, with a star to exercise its gravity around it, a system was created, the solar system. And of course, our home, planet Earth, which at its birth, was more like this. It is also believed that Earth suffered a huge collision. The giant impact hypothesis suggests that the Moon formed from the ejecta of a collision between the proto-Earth and a Mars-sized planetesimal, approximately 4.5 billion years ago. Analysis of lunar rocks suggests that the impact may have been a direct hit, causing a thorough mixing of both parent bodies. Because Earth had no atmosphere, it was constantly hit by meteorites and comets. We can see evidence of this, just by looking up at our Moon. This is how we believe water arrived on Earth. And with water, comes life. The earliest time that life forms first appeared on Earth is at least 3.77 billion years ago, possibly as early as 4.28 billion years. The earliest known life forms on Earth are putative fossilized microorganisms, found in hydrothermal vent precipitates. The most important event for life on Earth is the apparition of cyanobacteria. These bacteria pumped oxygen into the water and atmosphere. This event helped the formation of the ozone layer, so the Earth was now protected by the deadly ultraviolet radiation coming from the Sun. It is also believed that oxygenation of the oceans led to the Cambrian explosion. The Cambrian explosion was an event approximately 541 million years ago, in the Cambrian period when practically all major animal phyla started appearing in the fossil record. Life was mostly static before that. No organism could afford wasting precious limited energy. With an ozone layer and increased oxygen levels, life populated the land. Earth was now being dominated by plants and insects. Fast forwarding through a few hundreds of millions of years of evolution and natural selection, and 5 major extinctions. We now live in the world we know today. What exactly awaits us in the future? We don't know. But we shouldn't stop dreaming about it.